A very good morning, ladies and gentlemen. I am Ganji Shah, and it gives me immense pleasure in welcoming you all to the Infrastructure Automation Day virtual event on behalf of HashiCorp, Nivius, and Strategy. Ladies and gentlemen, each year, about 20% of every organization's total cloud costs are attributed to cloud waste. Over the next hour, we will hear how your organization can automate, standardize, and govern infrastructure provisioning with HashiCorp Terraform to increase productivity, reduce risk, and minimize cloud waste. From HashiCorp's Sandeep Madiraju, Senior Solutions Engineer, and Bharat Yaragati, Vice President, Customer Engineering from Nivius Solutions. With this exclusive event, we aim to highlight how teams and organizations must rethink their workflows by adopting cloud, while overcoming idle resources, over-provisioning, and orphan resources. Many cloud engineering teams today rely on manual checks to ensure that developers aren't provisioning infrastructure beyond what they actually need, because organizations have limited visibility and tracking of their infrastructure. Ladies and gentlemen, we would request you to please address your questions to our speakers using the Q&A option on your screens. Towards the end of today's virtual event proceedings, we would also request you to fill out the feedback forms. We would love to hear your feedback and suggestions. This will help us enhance the content, structure, and delivery of our conferences. With that, let's stay tuned for the next segment that's coming up on your screens.
Hello, and welcome to this webinar on how to control costs and minimize the cloud spend using Terraform. My name is Bharat Yaragati. I head the customer engineering at Nivius Solutions. We are a premier cloud engineering organization who have been working across various enterprises and corporates, helping them with their modernization journeys. So let me give you a quick background of Nivius Solutions. So let me quickly bring up my slides. Yeah. So we are known for solving complex problems with cloud engineering, as you can see, right? And we have expertise with the industries of BFSI, healthcare, media and entertainment, automotive, as well as digital engineering. We're based out of Bangalore, Delhi, Mangalore, Mumbai, Singapore, and Udupi, and supporting the APAC as well as the global customers. We were recently recognized as a breakthrough partner of the year for Google Cloud, for the entire APAC region, and also won a hackathon, organized by HashiCorp. We are close to 450 employees, and like I said, we have expertise with legacy application modernization, adoption of cloud technologies, API-centric business channels, multi-cloud strategies, smart analytics, right? Containers and orchestrations, API management, as well as CI/CD and MLOps modernization, right? So these are some of the key areas that we work in under infra modernizations. Like I mentioned, hybrid and multi-cloud adoption is one. Database modernizations, right? How to implement infrastructure as code. I think that's where our strategic partnership with Terraform comes into place. I'll talk more about that. Cloud native landing zone setups, managing the whole VMware GCV as well as disaster recovery. Right? Under the application modernization space, we have been helping our clients modernize their legacy applications, which is to run on a monolithic approach with the legacy stack into microservice and container-based modern applications, which can scale, at pretty much infinity level, which could bring the whole, move your products faster to market concept. Adoption of that makes it much more easier, as well as the cloud-centric CI/CD development, right? In the data space, we have been helping our clients build the data lakes, clear the whole data, run the ETL processes in the very modernized way using modernized tools, and then build your whole, analytics layers for predictive as well as prescriptive maintenance, and with all the visualizations. And across these three layers, we've been working very closely in implementing the entire cloud security operations, right, where it would be cloud, posture corrections. It could be security at your network level, app level, infrastructure level, and it could also be your zero trust policies, which we are kind of implementing for our clients. And then, of course, there's a site reliability engineering, which is the whole maintenance of it. Once you have moved your workloads to cloud, we help with maintaining it in end to end, so that you receive all the reports, all the regulations, compliance are in space, and how can we in a constant adapt, make it more effective and more efficient for your organization. So that's a quick background about Nivius Solutions. But that's not what we are here to talk about today, right? So our topic is on how to control cloud spend. So we have seen. I was just reading through a report recently, which basically said that close to 69% of the businesses are already adopting a hybrid cloud approach, right? And in the next 2 years, close to 90% of them would have adopted the hybrid cloud approach, and close to 97% of the IT leaders would be having a multi-cloud strategy in place. And we also have seen with our experience, especially because of the pandemic that happened, which was very unfortunate, but yes, that has kicked the whole cloud adoption in an exponential scale, right? Now with this also come challenges, right? Challenges in maintaining your multi-cloud, challenging in provisioning the infrastructure that is required, right? In the whole compliance part of it, the regulation part of it, the security part of it, and of course the cloud spend part of it, right? And here is where I think Terraform plays a very, very important role. And that's why we strategically partnered with Terraform in order to take the best of this tool to provision the infrastructure as a code to our clients. So we have been working in the space of automating the entire landing zone setup, which across multi-clouds, right, which otherwise takes sometimes weeks or even months, depending on the scale that you have. And how can we automate this landing zone setup based on your requirement using an effective tool like Terraform? It could even be setting up of an automated disaster recovery site for your organizations with a click of a button or based on a trigger incident, right? So basically Terraform helps you design your whole infrastructure as a code, which helps you basically build, change, and version your infrastructure in a more safe and an efficient way, right? It brings greater productivity within your developers who can start adopting it because they can start provisioning the infrastructure required for their workload without really having for an IT admin or IT guy to approve it, because you would have already configured these regulations and you would have already pushed these policies which they can start adapting, right? It could also help you adapt the kind of coding practices that you have in place, whether it's a code and the source code control or automating your tests. You can do that with HashiCorp as well, basically with Terraform as a tool, right? Other than that, we see a lot of under provisioning that happens, a lot of over provisioning that happens, a lot of data leakage that happens when you leave it open, and your IT team is trying to control all these things manually. I think this is where the automation or Terraform plays a very, very important role, which will help you optimize your cloud spend and basically reduce the cloud wastage, which is in billions of dollars, globally, which has been calculated by a couple of reports. And that is where we have Mr. Sandeep today with us from Terraform, who will walk you through the details of how can we effectively control cloud wastage using Terraform. So over to you, Sandeep. Thank you.
Thanks, Bharat. Hello, everyone. Welcome to the session. I'm Sandeep Madiraju from HashiCorp. I'm based out of Bangalore, and I take care of the pre-sales for the India and SAARC region over here, right? So to set the context for our today's session, I'm going to be discussing about, in addition to whatever use cases that Terraform brings, I'm sure most of you are using Terraform or know about Terraform and its use cases. So in addition to those, what is that the additional use cases that Terraform is going to bring to you, right? I mean, specifically focusing on minimizing the cloud waste, right? So we see that minimizing cloud waste has become such a hot topic and priority for most of these organizations, right? So with respect to Terraform and this particular feature of minimizing cloud waste, right, within Terraform, why is it so important and why is it the most used features among our enterprise version of Terraform is what we are going to be discussing today, right? So getting into it straight, so uh, looking at these numbers, right? So from Gartner, right? So you see that there's a huge amount of growth in terms of organizations adopting cloud and the spend that is there on the cloud, right? So you see that, I mean, it's close to 64 billion, and I think the latest numbers are around 86 billion, right? So for the last year, and of course, that might be due to the COVID pandemic as well. I mean, its effects are definitely there, right? But still, $64 billion is being spent annually on the public service, I mean, public cloud providers, right? So predominantly the AWS of the world, GCPs, Azure, Alibaba, etc., right? So, and there's a tremendous growth, right, in terms of the I mean, in the public cloud adoption, right? So you see that there's close to around 41% of annual growth that is there. And I mean, the next slide basically speaks about specific to each of the clouds, right? So you see that Each one of them, AWS, Alibaba, GCP, Azure, everyone are seeing a linear growth, right? So on a year over year, there's been a substantial growth in terms of cloud adoption, right? So which is a bigger thing, right? And it is important to put up these numbers over here because it shows the prevalence of multi-cloud environments, right? Which means that customers today are kind of adopting multiple clouds. They're not sticking to one specific cloud. Rather, we are adopting multiple clouds just so that depending upon our organizational needs, our workload needs, etc. Right? So we are embracing multi-cloud, right? So uh, now going back to that, $64 billion figure that we were talking about. So there's a lot that's spent in, spent on cloud waste, right? Of course, whatever we are spending in cloud, right, spending on the resources, on the cloud resources is not, is not 100% effective, right? Or we're not making the 100% use of it, right? So there's definitely some kind of a cloud waste. Now, what's alarming is the figure, right? How much has been wasted annually, right? So there's like $17.6 billion that's being wasted, roughly around 20 to 35%, right? So that's a huge number, right? So that's basically kind of the revenue of of a Fortune, say 200 or 300 company, right? So it's kind of the revenue of a particular company there, right? So we're spending this much amount of money in terms of cloud waste, right? So, and this is pretty consistent, right? So we see it with a lot of our customers in our day to day, right? So some organizations might have a higher number, definitely yes. Some might have a lower number, but uh, cloud wastage is happening today, and that needs to be addressed, right? Now, that's why we have this webinar today, right? So the session, so we're going to be focusing upon what are those opportunities to reduce cost, by up, I mean, how and how do we do that is by optimizing resources, right? So we should be provisioning those resources on cloud in an optimized manner and a controlled manner, right? So, right. So now, if we were to break down this $17 billion figure into buckets, right? So there are certainly two to three buckets that that you would see, right? So the first one is about idle resources, right? So we all have seen this in our organizations that most of the times there are resources that are being deployed, provisioned, and for the time being, it's being used, and later no one has bothered about it, right? So they just simply running there, right? So they're not using. They're provisioned, maybe for example in dev environment, and then people just forget about it, right? So that's about $11 billion wasted per year just on idle resources, right? And this also includes, if I have to differentiate it, I would say it's the second bucket. So the second bucket is basically orphaned resources, right? So we all know that, tagging, how important tagging is in the public cloud space, right? So if you don't properly tag your resources, or you do not have a proper tracking mechanism of your resources. So what happens is these end up becoming uh, kind of orphaned resources, and you don't have track of it. They're just running over there, and you're spending money on those resources, right? So this adds up to the $11 billion figure. And the third bucket now is kind of oversized resources, right? So now this makes about 38% of that $17.6 billion, right? So this comes up when you basically got developers, right? You give a free hand for your developers to go ahead and self-provision, self-service their infrastructure for their development needs and stuff. And that's where, because cloud is on demand, they can just go ahead and choose the sexiest and the largest resources that's available, right? So sometimes developers might choose GPU resources, right? Which basically, there wouldn't be a need for that particular resource at that point in time, right? To achieve whatever they're trying to develop in terms of the application. So, but then just because they have the provision, they have the free hand to go ahead and provision out of curiosity, or just that they've got the freedom to do that, they go ahead and provision these resources, but then you end up paying more for these resources, right? So that's again adding up to the waste. So now we did discuss a lot about unnecessary cloud waste, right? So there's I mean, in terms of oversized, orphaned resources, idle resources, all of these things. But is that all it? No, right? So there are other ways as well that organizations are seeing it in terms of cloud wastage, right? So the first one being reduced productivity, right? So for example, if today you're a Terraform OSS user, there is no real effective way for you to collaborate, right? Or your teams to collaborate and reuse Terraform code, right? So if they, for example, if the application team wants to deploy a feature of an application and they want to get that up and running as quickly as possible, now, they have to wait for the security team to go ahead and do some security, say port enablements, port forwardings, and stuff and things, right? So they want to wait for that, and then the network team, right, to set up the, I mean, infrastructure first. Maybe the network and the security infrastructure first gets set up, and then you get a say go ahead for going ahead and provisioning your infrastructure, right? So this basically is going to take a lot of time, right? And that means that, uh, I mean, you're going to waste a lot of time waiting for tickets to close, right? Now, second is from a risk perspective, I mean, there's a lack of oversight, right, at an enterprise level on how cloud resources are being provisioned, right? So there is no standard. Some teams might be well versed with the AWS GUI interface, right? Just to give you an example, some teams might be well versed with the AWS CLI of it, right? So and others might be using infrastructure as code, right? So someone who's well versed with the HashiCorp config language is using Terraform to go ahead and automate things, to go ahead and easily provision his stuff and things, right? So you've got a variety of ways that your teams are using in order to provision infrastructure, right? Now, that's kind of a risk because you do not have a control, right? So that's you do not have a control on, I mean, from an enterprise level on what's your standard way of provisioning and how do you control who can access what and do what, right? So that's adding to the unnecessary cost that we have been talking about, right? So now the great thing about our Terraform Enterprise or Terraform Cloud for Business is that it provides you a centralized control plane for how you provision infrastructure to the cloud, right? So instead of multiple Terraform open source instances running on multiple, say, developer laptops, right, across your organization, maybe sitting in the same building, different buildings, or even sitting across the globe, right? Now, what this results in is uh, the the state files are distributed, right? So kind of it's not in a centralized location. They're all over. They are in someone's laptop. They're, some of the state files are there somewhere in an S3 bucket or in external storage, right? Safe there, not properly versioned, the security of the state file not being taken care of and things, right? So rather than so there is literally no centralized place, right, where you can store your state files. So if a state file gets corrupted, there is no single platform that allows you to recover or I mean, kind of I mean, you can repurpose that, right? So you can't rebuild that state file over there. So what's happening is you really do not have a centralized platform or a single platform that allows multiple teams to collaborate, right? So you can manage your state file, everything centralized, right? So you can have that centralized. So that's where Terraform comes into picture, right? So the second is the security and the ops perspective, right? The ops teams can now be more involved, right, with how infrastructure gets provisioned. They can put uh, better guardrails in place and boundaries that the organization allows their engineers to deploy workloads in the cloud, right? So you can, I mean, they can go ahead and set, say, guardrails saying that no one in the organization is allowed to provision an S3 bucket which does not have encryption enabled, right? They can, I mean, you cannot go ahead and provision a GCP compute engine beyond this particular uh, machine, right? Maybe a medium or a large, right? So, or for your development teams, you can have a standard saying that all development work or teams should use small compute engines, right? So you cannot go beyond that, right? So this way you can have specific guardrails, right? And you can thereby have a higher level of control, right? And the last thing, of course, is self-service capability, right? Or with the private module registry, where I said, I mean, you can create your own modules, and this helps your teams, your developers, right? It's basically a shift left thing that's happening, right? So you can have your developers now use the pre-approved modules to go ahead and provision infrastructure, still adhering to all the organizational compliance and management requirements over there, right? So, so now that you see the screen, right? So this is basically the typical adoption journey, right? That a lot of our customers go through, right? So this is how they adopt Terraform, right? Phase by phase. To start with, I mean, in the adoption phases, like as I said, you start as a small team, you just download the Terraform open source binary, start creating organizations and workspaces, and just start going ahead and provisioning infrastructure, right? So this is like you've got multiple people running multiple instances of Terraform locally on their laptops, right? And then using it, right? Now, as the team grows, as the workload sprawl occurs, right? And then there's a need for collaboration and stuff. That's when customers engage with HashiCorp, right? And Terraform Enterprise comes into picture, right? And ideally, this this stage we call it the build stage, right? So where you've got multiple teams uh, provisioning infrastructure, you want them to collaborate, right? Enable collaboration between these teams, have greater level of control and stuff, right? With your, I mean, have integrations with your VCS and stuff. So that's where the build stage is, right? Now, once that's done, you go to the standardized phase, right? So where you now want to, I mean, once it is basically Terraform is adopted as a standardized mechanism for provisioning infrastructure, right? You go to the standardized phase where you now additionally want to have security and compliance baked into the provisioning phase itself, right? So that's where you get to, I mean, you get to have policy as code, right? So you use Sentinel, which is our policy as code engine, to bake in compliance and management policies into the provisioning phase, right? And once customers are standardized and seeing the benefit of Terraform, right now the innovative stage is where they want to go ahead and allow their developers to have self-service capabilities, right? So they allow the developer teams to go ahead and quickly self-service infrastructure as and when required, right? So that's the last stage. So the number that you see over here on the screen, right? So it's like I know it's a huge percentage, right? But then it's one of our life science customers, right? So they've seen close to 400 plus percentage on the return on investment by using Terraform, right? So we've got a use case on that. I'm going to speak about that in a few seconds from now, right? So uh, and this is not just with one customer, even with customers within the Asia region, right? So we've seen a lot of customers speaking about this figure very close to this particular number, right? And that's the effectiveness of Terraform, right? So yep, so we've seen the challenges, right? So we've seen a lot of cloud waste, right? So the results, Terraform basically, I mean, you see that 20% of the total spend is cloud waste, right? So Terraform allows you to minimize this cloud waste, right? So minimize your rate, I mean, increase your productivity, reduce risk, right? And ensure optimal usage of resources and optimal provisioning of resources and stuff, right? So that it decreases your cloud waste, right? So policy as code, again, as I said, optimizes your resource usage, right? So, I mean, it's going to reduce your unnecessary cloud spend rather than having, say, by controlling what type of resources you can provision, by not allowing people to just go ahead and provision any kind of an infrastructure, right? So, for example, like TPU instances, so you can have greater control and reduce the spend over there, right? And of course, as you scale up, you definitely are going to see savings increase as you scale, right? So this is like, I mean, we're speaking about a life science company just a few couple of slides back, right? So you see they had an, um, I mean, astonishing $4.5 million is cloud waste, right? So they were spending like this amount of dollars in with respect to the cloud waste, right? Now, With Terraform, they adopted Terraform, I mean Terraform Enterprise version, and then I mean they spent close to like 1 million on Terraform to completely automate their infrastructure provisioning and stuff and things, right? And the result is that they were able to eliminate this whatever the cloud waste is there, right? So close to near zero, right? So today the cloud waste is close to near zero, right? So that's the kind of savings that this particular company has seen, or this particular customer, right? Now, another customer, again, Cruise is an autonomous automobile company, right? So they've got 100 plus developers out there. Uh, I mean, managing hundreds of thousands of resources, right? So the beauty of this particular customer is that they've got, I mean, self-service capability given to their developers and developers, right? So close to around 150 self-service resources out there, right? They're configuring close to 1,000 resources or configurations are created per week, right? So every week they've got, I mean, they do close to 1,000 configurations, right? So that's the scale. And another very good customer of ours, right? So the Toronto Stock Exchange, the Canadian Stock Exchange, right? So TMX, 3 trillion, right? So the kind of the market capitalization that you can see, right? And then they've accelerated. Now, this is basically with respect to the reduced productivity or increase in productivity, right? So they had a huge wait time, right? If at all they needed some infrastructure to be provisioned, it would take them close to 6 weeks to 8 weeks, right? For in order to get that provisioned. Now that's with adopting Terraform, they have brought it down to a few minutes, right? So with all the standardizations with the private module registry and stuff and things, right? So they've given self-service capabilities, and that's basically drastically brought down the time that it takes for them to go ahead and provision infrastructure. And with that, they've also increased or basically decreased the time that they take for their application development lifecycle as a whole, right? So they see a 75% acceleration in terms of infrastructure provisioning, right? Right. So with all that said, what Terraform brings to you, right? So how Terraform, and this is the ultimate goal of it, right? So that this is what we wanted to discuss in today's session. So with Terraform, you can increase your productivity, right? So let's say, for example, with your VCS integrations, your pipeline integrations, right? So you no longer have to wait for your security teams or your ops teams to close tickets to have the infrastructure set, right? So you can have uh, pre-approved modules out there, right, which you can go ahead and dynamically or on the go, on the fly, right, use it in your pipelines and stuff to provision infrastructure and thereby increase your productivity, just like few of our other customers that we just spoke about have done, right? And reduce risk, again, a greater level of control, right? So you can, from at an enterprise level, you will be able to I mean, control on what's your standards, right? In terms of an organization, what's your compliance, what's your management principles, right? And what resources can be provisioned, what resources cannot be provisioned, right? So you can have all of these things. You can use policy as code, Sentinel, which is a policy as code, to enforce these policies, right? In order to reduce risk uh, for security, compliance, and operations reasons, right? And of course, audit logging as well. Reduce cost. So with Terraform, as we've been discussing, right? So you will be able to reduce your cloud spend, your cloud waste, right? So basically, whatever the cloud waste is, which is like close to approximately around 20%, you're going to be reducing your spend, right? So the cloud eliminate the cloud waste, and thereby you're going to be reducing your cloud spend, right? So uh, so that's about what I had to discuss today, and I'm sure this gives you a lot of insights as to how Terraform basically helps you reduce cost, right? So and increase your productivity, right? So the benefits of Terraform in terms of how your organizations can provision infrastructure, reduce the time taken to provision infrastructure and stuff, right? So with that, I'll hand it over back to Bharat. Thank you all once again for joining the session.
Thanks a lot, Sandeep. I think those were some brilliant stats, right? I mean, look at the cloud spend or the cloud wastage that happens globally. I mean, that itself would bring down an organization's whole revenue stream, right? If you look at it's in billions of dollars. And thank you so much for walking us through on how basically Terraform can help, right, in taking your products faster to market. How can you securely manage your cloud spend and bring it closer to the developers? How can we bring in that engineering agility with the use cases that you called out, right, which basically help these organizations take things faster to the market while they were able to provision all the infrastructure that was required in an automated way, in a controlled environment, and in a very secure environment, right? So increase productivity, reduce the risk, and optimize cost with Terraform is the mantra, is what I would say. So once again, thanks a lot for sharing this insight with us. I'm sure the audience here were able to get a grasp of how Terraform can basically transform their cloud journey and add in the whole process of boosting their businesses. We now throw open the webinar for any kind of questions. So please feel free to type in your questions in the Q&A sections, and we'll be very happy to answer them. Thank you once again for your time, Mr. Sandeep, and all the audience who have joined us. It's been great interacting with you, and I'm sure you have a lot to carry back on this. Should you have any further doubts on any of these, please feel free to reach out to us in the addresses shared with you, and we'll be very happy to get back in touch with you and take this engagement forward. Thanks a lot for your time.